Question number 9. In the diagram, the circle with the center O passes through F, S, H and G. So learners, here center is given O. We can see that is indicated there. So this one is the center, center here, which means FH is the FOH is what? It's the diameter, isn't it? And identify all the radii if we can, that is OF, OG and OH are the radii. It will help you for doing those questions. When you indicated radii, you can see a triangle, isosceles triangle OHG, which means these two angles are equal. Okay, so those up to that we got the information, isn't it? Okay, let's continue reading. DF and DS are the tangents to the circle at F and S respectively. So DS and DF, they are the tangents from the same point to the point of contact F and S. They are equal in length, which means DF is equal to DS, which means these two angles are there. That is an isosceles triangle, isn't it? DFS is an isosceles triangle. So we got that one also. F and F1 and S1, they are also equal, isn't it? Yes. But F1 and S2 and parallel lines also given. We can see that what are the parallel lines? SG is parallel to DF, which means DF, SG parallel. So we can identify those equal angles. What are they corresponding and alternate? F1 is same as S2, isn't it? F1 and S2, they are same. And we can see that S2 and H are also same because both are coming from the same arc FH, angles in the same segment. Did you see that? I will show you. From F and G, look at that, from F, let me draw it, and G. Can't you see that angle at the angle subtending at the circle? S2, very same F and G, we can see that another angle H, which means S2 is equal to H, which means all these angles are equal, isn't it? F1, S1, S2, H and G, they all are equal. So actually we are done. First question 9.1, prove that DSF similar to OGH, triangle DSF similar to OGH. See, we can see the evidence there, just the matter of writing it down, isn't it? Okay, so what are you going to write? So 9.1, triangle DSF and triangle OGH. OGH. You have to show that both of them are similar. Okay, so here how do you prove that? Just show that those corresponding angles are equal. That is, D is equal to O, S is equal to G, and F is equal to H with valid reason. Two pairs are equal. Just show that out of three pairs, only two of them are equal with the valid reason. Okay, start with the F1. I hope you saw those two triangles. DSF is the bigger triangle, and OGH smaller triangle, isn't it? You have to show that they are similar, showing that their corresponding angles are equal. Okay, start with the F1. So F1 is equal to, we already that proof is there on the diagram, just the matter of writing it down. That is, angle F1 is equal to angle S2, isn't it? So what is the reason? Alternate angles, isn't it? Alternate angles. Bracket we can write, alternate angles are equal, isn't it? So we got it, alternate angles, and you have to indicate the parallel lines. That is, DF is parallel to SG. Because of these two parallel lines, we got that one. And S2 is equal to H. S2 is equal to H. What is the reason? Angles in the same segment. Angles in the same segment, which means F1 is equal to H. We got it from there. Then how do you show that? So one pair, that is this pair is equal to this one, we did it. And if you can show that S1 is equal to G, they are equal actually. So how do you show that one? Because H is equal to, we can write now, H is equal to G. That is G1 plus G2. G1 plus G2. Angles opposite equal sides, isn't it? Angles opposite equal sides. They are radii, right? Okay. H is equal to G1 plus G2. Similarly, we know that DF is equal to DS. What is the reason? Tangents from the same point. Tangents from the same point. Same point. Okay, therefore F1 is equal to S1. Okay, therefore we can say that S1 is equal to, because what is F1? We proved that F1 is equal to H, and H is equal to G1 plus G2. Therefore, S1 is equal to, in fact, all these angles are same, isn't it? Okay, they are opposite to equal sides. S1 is equal to G1 plus G2. Then what is left there? And the bigger triangle D is equal to the smaller triangle O1. That is the third angle. Okay, so we can now say that a triangle, because it is already given the names in the question, so that order you can use. DSF is similar to triangle OGH. So we are done. Reason is angle, 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 isn't it? Okay, so this is how we do this question. Is it clear? Okay, let's go to the next question, 9.2. 9.2, it is further given that OG, where is OG? This line, OG is 7,5 units. Then RH is this one, 1,5 units. Calculate the length of SG. So you have to calculate 9,2, length of SG. We have to find the length of SG, that is from S to G, this length. Okay, how do we do that question? Guys, SG, we can see that theorem number 1 or 2, or from center, if you draw a line, if this line is perpendicular, then it's going to bisect SG, that is SR, these two are equal, isn't it? Okay, so how do you prove that? You have to show that it is 90 degree. Is it 90 degree? Yes, it is 90 degree. We can see that again, go to parallel lines. We know that this, look at here, I will show you with the red ink. Did you see alternate angles? This is the alternate angle, isn't it? So this one is 90 degree. What is the reason? The angle between radius and tangent, and we can see that is equal to R. So alternate angle is going to work. So we can say that ORG, or we can write it F1 plus F2 is equal to 90 degree. What is the reason? It is radius perpendicular to tangent. Okay, then ORG, angle ORG is equal to 90 degrees. What is the reason? Alternate angles. Because DF is parallel to SG. Is it clear? Okay, so this one we prove that's 90 degree, which means SR and RG, they are equal. Therefore, SR is equal to RG. What is the reason? Line from center perpendicular to the chord. Line from center perpendicular to the chord. Perpendicular to chord. That is the first theorem, isn't it? Okay. Now, how do you find SG? If you know RG, did you see a right angle triangle and OG is 7, 5, then what is, isn't it OG and OH, they are radii, isn't it? OG and OH. And from R to H 1, 5, then what is O to R? 7, 5 minus 1, 5, isn't it? Because OH, that is OR, is same as OH, that is a radius minus RH. Do you agree that? Okay, what is OH? 7, 5 minus 1, 5. So what is that? It is 6 units. That is, this one is 6 units. Now can you find RG? RG, so we can use Pythagoras, that is 7, 5 square is equal to 6 square plus RG square. If you know RG times 2, we will get SG, isn't it? Because of the theorem. We know that SR and RG, they are equal. Okay, now we can solve and find the value. That is RG square is equal to 7, 5 square minus 6 square. So RG, when you do it, you will get answer is 4, 5. That is half of SG. We already know the reason is line from center perpendicular to the chord, bisect the chord, isn't it? So therefore SG is equal to 2 times RG, that is 2 times 4, 5. Answer is 9 units. So this is how we do this question. So here we used alternate angles and we used line from center perpendicular to the chord and Pythagoras. Those who are good at that, this question easily you can do it. Okay? All right.